Hey guys, so how do acids interact with other substances? What are acid-base pairs? And what does getting older have to do with it? Now it's all about acid-base reactions. It's one of the most important reaction types in chemistry. If you make sure that you understand this concept, you can use it over and over again. Just note, protons are transferred in these reactions. Protons are H+ ions. If this reaction type were a play, they would be the lead actors. You can also remember that the oxidation numbers stay the same with acid-base reactions, contrary to redox reactions. To understand acid-base reactions, you should first understand what acids and bases are. Well, this guy called Bronsted claims that acids are proton donors. And what do donors do? That's right, they donate. So acids donate protons. Wow, those acids are just so generous. On the other side, we have the bases, our proton acceptors. Well, to accept means to receive. So bases receive the donated protons. In a sense, the base is the beggar and the acid the kind-hearted giver. Famous acids are hydrochloric acid, HCl, sulfuric acid, H2SO4, and also carbonic acid, H2CO3. If we add these acids to water, things turn sour. To put it differently, they donate their H+. Alright, well, time for a practical example. What happens if hydrochloric acid reacts with water? Well, the hydrochloric acids donates its H+, which leaves Cl-. Now, the H+ needs to go somewhere, so it decides to go to the water. Let's think for a second. H2O plus H+ together results in H3O+. HCl donates the H+. It doesn't have a choice, it's an acid. The water accepts the H+, so water is a base in this example. Now let's move on to the general terms we use for this. The acid left is called acid 1. Here, water is our base, and it's called base 2. Why 2? Well, you'll find out in a sec. If we now look at the right side, we will find a Cl-. This is perfect for accepting an H+. On the other hand, H3O+ can easily donate another H+, for example, to the Cl-. Therefore, you can determine that H3O+ is an acid and Cl- is a base. To make it clear which substances belong together on the left and right, the chloride ion is called base 1. It has the same number as the hydrochloric acid. This makes the oxonium ion or H3O+ acid 2. 2 just like water. The acids and the bases with the same number are then called conjugated acids and bases. Conjugated simply means that they belong together. And together, the acids and the bases make a conjugated acid-base pair. In our example, pair 1 and pair 2. The cool thing about this is that you can describe any acid-base reaction with this model. And it gets easier every time you use it. We just looked at the important acids. Now, we'll turn to the famous bases. For example, we have ammonia, NH3. More famous bases, caustic soda, NaOH, caustic potash, KOH, and lime water. They have an alkaline reaction with water. This means that they accept an H+. Let's take a look, shall we? Here, we have ammonia and water together. Ammonia can accept an H+ ion. This makes ammonia our base 1. Well, this means that water must be an acid, making it acid 2. If you want to switch around the numbers, feel free to do so. It's only important that you can assign the pairs correctly afterwards. Okay, so NH3 accepts one H+ from water. This produces NH4+, and the rest of the water turns into OH-. Well, that's the entire equation for the reaction. Now, let's take a look at the pair on the right side. NH4+ can donate an H+, therefore, we'll call it acid 1, which leaves OH- as base 2. It's longing for an H+. If the H is then transferred to OH- again, we get NH3 and water. This results in two acid-base pairs, and that's how we get older. H+ equals Age+. Get it? Okay, it's really always about the transfer of H+. Now, acids and bases do not really need to react with water. They can also react with each other. Let's take the following example: hydrochloric acid and ammonia. Again, we have our acid 1 and base 2. Hydrochloric acid donates its H+ and ammonia, that old beggar, accepts it. This gives us Cl- and NH4+. Here, Cl- is the base and NH4+ the acid. Now, we just need to add the same number as the conjugated acid and the fitting base from the left side. Cl- is base 1 as it belongs with acid 1. Or, to put it differently, NH4+ is the conjugated acid of NH3. Therefore, both get a 2. So remember, with acid-base reactions, protons are transferred from the acid to the base. The acid turns into the conjugated base and the base into the conjugated acid. And these are our acid-base pairs. This concept is incredibly important and you'll keep on using it in chemistry. Make sure you understand it. Get cracking!